welcome to The Jump. It is going to be an exciting couple episodes coming at you. We are going to be tackling intelligent learning technology in corporate education. And how we're going to do that is we're going to be bringing in a handful of different subject matter experts per episode for the next few episodes where they have a passion for learning and development. So to kick it off, Charles Dunn, a familiar face from multiple Jump episodes, is joining us today. Hey, Charles, how you doing?
I'm good. Thanks again for having me, Rich.
Thanks for being on. And I'm going to ask you a couple of pretty technical questions. I know this is your bread and butter, but kicking off our discussion today, let's start with immersive technology. This has something that has been paired up with education for a while, right? When you're talking about the use of the metaverse or, basically putting on goggles and being able to go to different locations and learn through that way. It has been something that has been discussed for many years. But before we dive into realistic use cases, can you provide examples of the three popular areas when we talk about virtual reality, mixed reality, and extended reality? Can you start there and then we'll jump off from there?
At kind of like the highest level, we have virtual reality, which is a fully simulated world where you're putting on goggles and everything around you is simulated. The mixed reality is this idea of you have digital objects that are being combined with real world objects. Some features of the goggles where they have cameras and are able to project digital objects over a projection of the physical world. You might see this trying to see what a couch would look like in your living room, and they just project the couch in there. There's also this idea of augmented reality, which layers digital elements over a physical world. And this could be digital labels, for example. There was a demo for the Apple headset, which showed a person cooking, and over each pot on the stove, there was a timer for how long it needed to be there. So it's not a digital object that's interacting with the physical world. It's just a presentation over the world. And that's a useful feature. It's not $3,500 worth of useful, but it's nice. And all of this is part of the umbrella of extended reality, where you have some aspect of digital projection over the physical world.
Got it. Wonderful breakdowns. For our discussion and purposes here today, instead of going, hey, mixed reality, augmented reality, extended reality, let's just look at it from a macro perspective. You as a trainer, when you are thinking about what version of virtual reality, or let's just say virtual reality in general, how can that be used either right now or in the real near future to make the biggest impact?
Now, I think at this point it's fair to say that the metaverse has been a failure. It has been a multi-billion-dollar attempt to make something that audiences did not want and are not interested in. The hardware is too bulky. The virtual worlds are too incomplete. And it is not something that we are going to see integrated into our daily lives the way it has been marketed anytime soon. But the idea of using digital components with physical reality is something that is always going to be interesting. Just the basic idea of a virtual classroom, the idea where everyone is in different physical locations and they're projected together, that is an element of extended reality. You are adding digital elements into a teaching space. The idea of having notes, additional context, additional material that is being projected in a learning environment is something that can help students who need it while not interrupting the flow of a lesson. If the lesson is live, this could be something that is interactive. If it's an e-learning component, that could be an element of, hyperlinks to additional resources on a topic that students can use at their own pace. And all of this is actually fairly low tech comparatively. This is not something that requires really complicated hardware to do. It just requires creative integration and creative engineering on the part of someone facilitating a lesson.
So when I'm hearing you explain all of this, all I'm thinking about, well, I'm thinking about a lot, right? I don't want to downplay that all, but it sounds like such a great idea. Just being able to, hey, if you say a term that I'm unfamiliar with, maybe it instantly pops up with the definition and an example. Maybe if I'm learning how to put something together, I can get a virtual version of that. We'll get into that one in a second. But does it come down to the comfortableness of the hardware? Like if, Apple's Pro was a failure. They literally have shelved it. Right? They even tried to do a cheaper one. I don't even know where that's going. The Oculus is fun for games, but I can't see myself wearing it for, more than 2 hours.
No.
Does it come down to the hardware? If the hardware never gets to a level where somebody can wear it for hours on end and not have a headache or not have your ears hurt or whatever it may be, is it a lost cause?
If the hardware is not comfortable, it will never catch on.
Mm-hmm.
That is a simple fact. As of right now, the full VR headsets are a niche tool for some video games or very specific design applications, like people who work in industrial design. That there's a specialty brand of industrial design headsets or artistic design headsets that are prohibitively expensive to any industry that's not in this field. And those work great for those specific applications. Mm-hmm. Meta is trying to go into the market by working with Ray-Ban to get like little glasses that are really lightweight that integrate all of Meta's stuff into it. But we have not seen at time of recording if that's going to catch on, because yes, the hardware is comfortable, but it's also really creepy, where you have a camera staring out of your eyes at everyone that you're interacting with. That yes, it can provide all of that digital augmented reality, but we don't know yet if the fact that it's a camera that's transmitting everything that you do to a server somewhere is something that general audiences are going to want or want to interact with the person who's wearing them.
You got it. And there's another piece too where somebody created a necklace that records every conversation and then can do the AI notes from it. You're running into a Black Mirror episode, an actual Black Mirror episode in the situation, right?
Yes. Cyberpunk is dystopian fiction, not aspirational fiction.
And Cyberpunk is a popular video game, just in case. You're spot on. There's going to be some challenges to this, but the finish line of being able to utilize virtual reality in an educational setting, do you feel like that is probably one of the more impactful technologies for learning if it's done right?
A learning environment is a controlled environment. It is a space that with you are entering with consent to have information be presented to you and to have the things that you are interested in learning be adapted to. Let me put it that way. So it, rather than walking around with your meta glasses recording strangers, a classroom is a place where everyone knows each other. You're the instructor and your classmates. It's an environment where these kinds of virtual projections can be limited to the specific context of what you're learning. And it's a place where there's a lot of factors you don't have to control. The headsets have to work in everyone's living room. A learning environment can set aside a specific space for that. You're able to limit the context, control external factors, and this enables a more focused and limited integration of digital objects.
And that's always the game plan, is to get to that customized experience for that specific topic. Somebody who understands, a subject matter expert in a certain area as opposed to a jack of all trades.
Mm-hmm.
Right. So, Charles, while we're on this, it's important, I think, for the audience to also be aware of digital twins.
Yes.
Similar realm here, but can you explain to us what digital twins are?
So, a digital twin is very simply, a digital representation of a physical object. And this digital representation is as complete a model as is feasible. The more factors that impact the physicality of the object, the better the digital twin. So this could be, if you're doing industrial modeling, it could be the forces acting upon the physical object. If you're trying to see, like, will this component break if this amount of tension or torsion is put on it, you don't have to build one and then break it. You can have an accurate digital twin of it, perform the calculations, and say, okay, this much force will break it. And if it's a good digital twin, when you actually run the test in real life, it will perform the same. So the more physical factors you can control, the better the digital twin.
That has to be so time saving. That has to be cost savings. There's a huge benefit to that. A lot of our audience is in the development space, developers. How could a digital twin be used in training for a developer?
So I'm going to use an example of something that probably most people will find fun and something that I'm interested in, especially for their near-term applications. Let's talk about robots.
Cool.
If you are trying to design a robot, you need to write the code, and you also need the physical little robot to do the thing. A digital twin will allow you to see the outcome of code immediately without having to build the little robot yet. It'll see not only the physical effects that your code will have, but also places where it could fail, and then reset the test without having to rebuild the robot. So digital twins as a rapid prototyping tool is very powerful, very useful. And one thing I want to stress, I'm using physical examples because they clearly illustrate the effect, but it doesn't have to be a physical object with a digital twin. It could be a digital twin of a distributed network system that could simulate an enterprise scale application scaling up to multiple servers in a cloud environment, but without actually having to do all of the networking configurations that would make that physically happen. You can develop software, run tests, run simulations, see if it works before having to do whatever underlying infrastructure is necessary to actually make it exist.
Got it. So even like a performance testing.
Performance testing is another good example, yes.
Okay, got it. So these digital twins, how much are they used in a corporate learning environment? There are still restrictions or maybe cost factors to get the technology that's able to create these, though, correct?
Yes. Depending on the complexity of the digital twin that you're working with, and depending on how generous you want to be with the definition of a digital twin, if you want to be as generous as possible, any kind of demo environment could be considered a kind of digital twin. Any time where you have simulated space that requires less resources than attempting to perform that on a production ready instance, that's you are taking advantage of the principle of digital twins. As resources get better and better, you're going to see more sophisticated digital twins being more readily available. You could spin one up immediately for a classroom demo and then spin it down as soon as you're done.
I'm 100% guilty of when you're explaining digital twins and you're talking about the little robot. I'm picturing like Obi-Wan Kenobi holographic popping on up, or, in a lot of movies they show, I guess you could say it's what, augmented reality.
Yeah, yeah.
When you're saying spin it up, is that the vision that you're also having in mind, as opposed to where it is now? It's probably just a screen with numbers or, graphics. But do you think it could spin up into more of a virtual reality digital twin?
Yes, yes, absolutely. You could go the full headset route. It's definitely something that, if you're dealing with a digital twin of something physical, then you could easily put that into some kind of 3D engine. Things that are very popularly used as game engines, also capable of rendering the physics of any kind of physical object. So you can use this technology that makes all of these beautiful virtual worlds that are used, notably, not for the metaverse, because that was ugly, but nice looking video games. You can use that same technology to render something either, in the VR headset or even just on a computer screen. And again, it's a scale of cost to immersiveness. Like, it's, yes, you could spin up a digital twin on a headset, but it might be cheaper to spin one up just to project it, on your nice 2D laptop that you're probably using right now.
And that's fair. I have a question that you and I haven't discussed previously, but I was just curious. We're going to talk about AI agents. Is
Mm-hmm.
there, when you're talking about digital twins and you're running experiments, is it something that realistically, the way AI agents are moving with their autonomous, multi-iterative responses, basically, right? When you ask a query, could it change those tests and provide you with that ideal match to the reality?
That is the goal.
Mm-hmm.
So far, everything I've been talking about, as I mentioned earlier,
Mm-hmm.
comparatively low tech.
Yep.
3D rendering engines, hyperlinks, even, though all of that is classic technology.
Mm-hmm.
Modern technology, the hot technology right now, AI and AI agents, can be used to automate a lot of this. So if a digital twin has an AI agent associated with it, changes that could happen to the physical digital twin component can be acted on by an agent. You can have not just static simulations, a static digital twin, but an active digital twin, a digital twin that is programmed to not just experience forces like the physical one, but act as a physical one. Once again, to go back to our robot example, you could make an agent that will move the robot, the digital robot, through a virtual environment in a way that, not just in a way that the physical robot would, but massively parallel, act in every way that the physical robot could, all at the same time, and react to stimuli all at the same time. So, like, agents, you can have it act in parallel. It's just a simulation. It can do all of these things at the same time and then report on its findings. All of that much orders of magnitude faster than a physical one would.
So the speed of learning, when you're combining, let's say, digital twins, virtual reality, or some version of it, and say AI agents, you're potentially doing 1 day of class of what would previously have been weeks of just setup alone.
Yes. Now, I want to bring this specifically into the realm of education. So far, we talked about something kind of fun. We're building a robot. But let's go back to the idea of a non physical digital twin. What if you had a digital twin of a learner in a classroom?
Mm-hmm.
So now we're not using the digital twin as the object of what we're studying. We have a digital twin of someone who is trying to learn. And we feed that digital twin, and that digital twin has an agent or a few agents associated with it that are trying to optimize this learner's retention of information. And so you have the physical learner who is performing tasks, who is absorbing information, and then trying to prove that they have this information, either through exams or exercises. And so you have the results of exams, the results of exercises. You can give that to the digital twin of the learner. And then over time, as a learner performs better or worse on certain elements of what is being taught, the agent can optimize or customize a learning path or a study or material to study based on the performance of a learner. Like right now, we have learning paths that increase in complexity, which is good. Like that's good. That's a great way to learn. But there are certain things that certain people will find more complicated than other people will. So if you're learning C++, you would have like something really complicated where like increasing in complexity. You learn variables, you learn arrays, you learn pointers, you learn objects and classes. If one person performs really well on pointer logic,
Mm-hmm.
and another person doesn't do well on it, but then when it comes time to object oriented principles, it's reversed. An agent could give extra study material that diverges per learner based on their previous performance.
That would be incredibly impactful. It goes back almost to conversations that we've had previously on benchmarks. When we go
Hmm.
through the testing, it's all the same for everybody, or SATs. That's not how people always learn. And so this would be able to customize that approach per individual. I know we have one more question too, but there's a book called AI 2041. It's actually the black one right over there on my shelf. And they have a chapter, I believe it's called Twin Sparrows. It's been a while since I've read it. But in there, they have a virtual classroom where the student was the only real person. And what they had was the peers, or his peer students, I guess, with him, all be built to help get him to the right outcome. So there was somebody who would motivate him in order to study. There would be somebody who asked questions that they felt that needed them, the individual initially, to ask. And so it was kind of in the same realm that you're talking about. They've done stats or potentially a digital twin behind the scenes that needed these areas of focus and then implemented that in a completely virtual environment. So it was pretty mind blowing, but I think correlates with really what we're talking about here today.
That is a waking nightmare.
That really is. So that's something that we have to look forward to in
Hmm.
2041. So right around the corner. Charles, my last question to you, and one I really wanted to get into with you is yes, you facilitate day by day. I think you put in some of our larger amount of class hours.
Mm-hmm.
You are, though, you're truly a developer at heart. And so, with that in mind, my last question to you today is how are you already using coding assistants, like a GitHub Copilot, in a corporate learning environment?
So there are two important facets of the prevalence of coding assistants. And they're both important. Not one does not supersede the other, but one is good and one is unqualifiably bad.
Okay.
So the good thing about coding assistants is that it is a very fast way for a learner to see an actual implementation. So if a learner is struggling with something, they can see the correct answer immediately.
Mhm.
Why am I getting this output? Why am I getting this error? The coding assistant can understand and tell them. This is unqualifiably good. It is good to see a potentially really complicated solution to a complicated problem. It's a way to allow a person to see patterns that might have been invisible to them before. This is how this problem is solved. Oh, here's a similar problem. I remember how this was solved before.
Mhm.
Because these models are built on massive code bases, they can see the optimal way that an entire community has solved a problem already.
Mhm.
So it really does bring someone up to speed. It enhances the speed at which they are able to learn from previous examples.
Got it.
But there's also the other factor,
Mhm.
and there's no getting around this. And that is coding assistants will just give you the answer. And it is human nature to see the answer and just do that. There's no way to spin this as a good thing.
Mhm.
People are using ChatGPT to cheat on their homework. People are using coding assistants to solve their code problems. And this is not a good way to learn. People are not learning if they're using coding assistants like this. And yes, if you're a senior developer and you've already solved this problem 100 times before, you know the solution, you just need the boilerplate spit out for this specific context,
Mhm.
that increases your productivity. But if you're trying to learn a topic, the coding assistant is extremely good at giving answers to classic homework questions. And if you can't solve the homework questions, you'll never be able to solve the more complicated problems that the model has never seen before and won't give you good answers to. That's a problem, and you have to work around that as an instructor.
And that's the beauty, though, of having an instructor like yourself, is
Yes.
you're going to tell somebody that. And if you look at it for all of our junior level individuals or folks who are wanting to get into technology, you're going to be looking at a very large population of people who have the same exact skill set, that being the coding assistant, and all the same. What
Mm-hmm.
you have to do is really instill in yourself the critical thinking piece, the curiosity or inquisitive aspect of, hey, how can I do this by myself? How can I fill in a gap? And that's where you have an instructor or a mentor to help walk you through it. For the coding assistants, if you are doing it in the right fashion, for instance, hey, look, I know how to save myself time. I know how to learn through reading what is generated, kind of maybe bridging that gap that I might just be missing. I need to get over the hump there.
Hmm.
Then an excellent support in a classroom experience, is that, would you lean on that side? Let's assume that somebody's doing the right approach.
As a learner, you have to have curiosity. You have to be interested in the topic. As an instructor, you have to learn how to instill that curiosity
Mm-hmm.
in your learners. The coding assistants are a fact of life now. The coding assistants are here to stay, and you have to understand the you have to understand their uses and their limitations. And as a learner, you have to be prepared to go past the limitations. You have to want to learn, and as an instructor, you have to tell students why that is exciting, why that is interesting, why that is fulfilling personally, to be
Yeah.
able to build something really cool and really complicated, to see the coding assistant as a vector, C++, a C++ joke, as a vector for all of the really cool things that you can build for yourself, and have this as a way to augment your learning rather than as a way to just get your homework done.
Instruction is no longer just checking the box in some cases, and it never should have been, for the record. But there
Mm-hmm.
has to be value facilitation. What is the reason in all of this? Because otherwise, everybody will cheat on your tests, and you'll ask, why is everybody cheating? It's because you, as an instructor or a trainer, right, did not provide the value for the hard work. You have to throw out the checkbox mentality. Homeworks, assessments alone, it doesn't prove
Yeah.
anything anymore.
As
So
I like to say, if ChatGPT can do your homework, that's a sign you have to fix the homework.
that's really what we're talking about. Hey, there are all these technologies. It's going to make learning better. But if you just resort to, hey, okay, cool, you attended the class and that's it, you accomplish nothing. We are now getting the power to get in the weeds, customize training for every single learner, which has proven time and time again an increase in capacity as well as speed for the knowledge that they're able to relate. You have to do that. If you're going to be an instructor, a manager, a mentor who just says, okay, cool, it's done, whatever, it's going to end up biting you in the tail. So, Charles, phenomenal inputs for the jump and our limited series here today. I'm Rich Bowers. Thank you, everybody. Take care. Thanks, Charles.